Hello, good day, doctor. My name is Srishidaran Sivalingam. My matrix number is AE190040. I'm going to explain my part, which is introduction. So, first of all, what is RLC? So, RLC circuit is stands for R as resistor, L as inductor, and also C as capacitor, which can be connected in series and also parallel. So, all the elements are linear and passive in the nature of RLC. So there are many number of ways to connecting this element across the voltage supply, but the most common method is to connect these elements either in series or parallel. So since all the components are connected in the series current, each element remain the same, and the total voltage for the RLC circuit is not equal to the algebraic sum of voltage across the resistor, inductor, and also capacitor, but it is a vector sum because in the case of a resistor, the voltage in the phase with the current. For the inductor, the voltage leads the current by 90, and for the capacitor, the voltage lags behind by current by the 90. So RLC circuit will work efficiently when voltage in the capacitor causes the current flow to stop and then flow the opposite direction. So RLC circuit is more important because many applications does involving in low and high frequency signals. So there are applications which in oscillator circuit such as radio receiver, television sets for the tuning process. So in this project, uh, we must have a non-sinusoidal AC input signal. Fourier series analysis is used in this project as requested. So can this Fourier series can be defined as periodic functions in the term of infinite uh, plus of a sine and cosine function. So Fourier transformer is also used in real life as a designing, modifying electrical circuits such as filtering, solving differential equation, image processing, and many others. So to confirm the values that we obtained from the manual calculation, we have used a MATLAB simulink for circuit simulation. So that's all from me. Thank you.
Hi doctor, I'm Karthi Pushpanathan. So this is the circuit that we have chosen. So the voltage input is in a pulse form. So it has a maximum of 8 voltage. So we have derived it. 8 is from 0 to 1 seconds, and then it is 0 at from 1 to 2 seconds. So we can calculate the omega over there. The period of this waveform is 0 to 2. So the period is 2. So 2 pi divided by 2, we get pi. Then we can move on to A naught, where the formula is 1 over t, and then we integrate ft from 0 to 1. So we get a final answer of A naught equals to 4, and we can move on to An, where the formula is 2 over t. Integrate ft from 0 to 1, and the formula is cos n omega t. The n omega is the A, then dt. So once we integrate, we'll get 8 over A and omega bracket sine A is the n omega, n pi, t, then we substitute 1 and 0 seconds, and we get a final answer of 0 for An, and then we can move on to Bn, where the formula is slightly different. We are using a sine over here instead of cos. So once we integrate, we will get negative 8 over A is n pi, and same comes here, A, but cos n pi, then we substitute 1 second and 0 seconds. This is the final answer that we get, but we assume that the n is in an odd number, so we get a final answer of 16 over n pi, and this is for DC, and this is for AC. So for DC, for DC we get 4, and 16 pi 1 over n sine n pi t is for AC. Now I'll move on to the next slide. So in this slide, we'll be finding VS1, VS2, and VS3. So for us to find the V, we need to use a formula of whole square root, A1 square plus B1 square. So we don't have A1 in this case, so we just have B1 square. So 16 over 1 pi square. So we get a final answer of 16 over pi. So same comes to all the other two values, but Just the difference is the n is difference. In this case, we are using 2, and in this case, we are using 3. Otherwise, the angle is same for all the values, just because inverse tangent infinity, so we just get negative 90. So that's all from me, doctor. Thank you.
Hello, my name is Morgan. My MATI number is DE200111. And next, we are going to find the impedance of the circuit, the impedance of the elements for resistor, capacitor, and also inductor. So the total value of impedance will be get like 18s square plus 24s plus 24. And then we find the V naught of the circuit. So we use the total impedance, value of total impedance, and also the value of amplitude, and also the value of the phasor, which is Vs1, V source 1, which means the value of n is equals to 1. So after we calculate, we will get like the value 12s over 9s square plus 12s plus 12. And then we find the voltage. In the question, it will be asked that we need to find the voltage at each node. At each node of the circuit means we need to find the voltage for each components, resistor, capacitor, and also inductor. Okay, so for V01, we use 12s divided by 9s square plus 12s plus 12. So for that, for s, we substitute j and pi in the equation, and then we will get the VR1, which is 2.2436 angle negative 153.86 voltage. And then we find the same thing for VR2. We will get a 0.5462 angle negative 167.61 voltage. And then for VR3, we will get a 0.2414 angle negative 171.83 voltage. And then after we combine it, we can make a amplitude spectra. And then after that, we need to find the current. We use the total impedance 18s square plus 24s plus 24. We find the current I1, which will get like 0.01311 angle 52.28 ampere. And then for I2, it is 0.777 times 10 power of negative 3 angle 24.78 ampere. And then for I3, we will get like 0.1517 times 10 times by 10 power of negative 3, 16.34 degree ampere. And then finally, we need to find the voltage, the power of one of the components for resistor or inductor or capacitor. So in this case, we want to find the power of resistor. So we use the formula of P equals to I square R, and then we calculate, we will get like 1.0312 times 10 power of negative 3 angle 52.8 divided by 5 watt. So that's it from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Razak bin Ahmad Syukur, and today I will do the simulation for our project. So this is our circuit. It's a pulse input of 8 amplitude, the resistance of 6 ohm, capacitance of 0.125, and finally the inductor of 6. So next we will determine the voltage through each the component. So the first one is the resistor. So we get the value through the resistor is 2.1024. So for our voltage through the inductor, we get 584.415 millivolt. Finally, for the voltage through the inductor is 240.357 millivolt. So the next one we will do the current through each the component. So firstly, for the current through the resistor is 12.239 milliampere. Next, I will do the current for the capacitor. So we will run, and then we can see that the current of the through the capacitor is 666.665 milliampere. So for the current through the inductor, we get 133.33 microampere. So I think the next is the power for the resistor. So we get the value of 0.001759, or we can simplify as 1.759 times 10 to the power of 3 watt. So I think that will be all from me. Thank you.
As for the final part, I'm going to explain conclusion. So the multi-sim software and the many simulation programs are available for the professional and students, engineer, and anyone else interested in these circuit subjects. So the computer simulation, which is often used to solve the complex circuits, which can the simulation circuits can be done with a simple way. So the simple circuits becomes much more easier to deal with the ones with the concept to understood well. So Fourier series is a prerequisite for developing a solid foundation in understanding the time domain and also the frequency domain relationship with the good communication signal. It can be used to express the non-sinusoidal periodic function into a fundamental and harmonics, which can represent a function containing discontinuities. So the function which is discontinuous can be represented by the Fourier series. An expansion of an oscillating function by a Fourier series provides all the modes of the oscillation. So that's all from me. Thank you.